Okay, everyone. So let's get started with lecture for today. So yeah, this is our last week of lectures. So yay, congrats on making it this far. This week we're going to be talking about images, which is if you were at the hack challenge kickoff earlier today, it's one of two things. Like you can choose between either implementing authentication or images in your app, and it's required as like the backend portion. So if you didn't really like authentication last week, make sure to pay attention to images this week. Maybe you might like this a little better. So just like last week, we do have two guest lecturers. I'll have them introduce themselves real quick, and then we'll go into a couple of announcements before then. So yeah, take it away.
Hello, my name is Caduce.
Oh wait, come to the class.
Hello, my name is Caduce, and I'm on Backend, and I'm currently working on Eater. It's cool.
Hello, I'm Bella, and also obviously I'm on Backend, and I'm currently working on Uplift.
Oh yeah. So we'll be talking about images today. Before that, just a brief couple of announcements. Okay, so if you've checked Ed today, we released the mentor preference form. So you'll get assigned a mentor for your hack challenge project to kind of guide you along the way, maybe like check out your ideas, help you with implementation of certain things if you have any questions like that. We released a video that you can watch, just like all the people on the core staff like introducing themselves. So if there's anybody you would like to be your mentor that you want to like put down, feel free to like check out that video and put your preference down on the form that was released. Ideally, you can submit by tonight, so we can just release your mentors tomorrow. But if you want to do like early tomorrow, that's fine too, because I probably won't get to it until like the afternoon. So yeah, just get to it before I see it tomorrow afternoon, and we can give you a mentor of your preferred choice. Otherwise, like you'll just get assigned somebody on the core staff, and everybody is very helpful and very knowledgeable and willing to try to make your project the best that it can. So there's no way you'll get a bad mentor. And mandatory mentor check-ins before the end of the week. We'll post more information about that again on the ed, but do make sure to reach out to your mentor by email or by any other maybe form of contact that they give you and schedule a check-in with them before the end of the week. This is just to go over like some of the requirements for your midpoint check-in that's due at the end of the week, whether that be like your API specifications or your like database design. Your mentor will kind of like go over that with you, see that everything is like okay and ready to go for your midpoint submission at the end of the week. Yeah, and next is just to review Git. So you're going to be working with like a cross-functional team between like front-end people as well as like a back-end partner if you have one. You're probably going to use GitHub as your main source of like communication in terms of like code control, version control, in terms of like versions of your code. There's a Git lecture posted on YouTube, so make sure to review that and not get too lost in the Git sauce for this coming hack challenge. It's the last week of this class. Come to lecture on Wednesday because there will be Kahoot prizes for people who have been doing very well in the Kahoot. So yeah, and just general, I guess, like celebratory last lecture stuffs. And then if you want to improve any of your grades on any previous assignment, make sure to submit that before this Friday at midnight, and we'll be like grading those as they come and updating grades. So yeah, just make sure to keep that in mind as well. Okay. With that being said, Caduce will come up and start talking about images.
Hello. So this lecture is about images and how to store images into your database. So we'll just get right into that. So imagine you want to like create a website that like sells fruit to your local fruit buying place. And if you had a database, you would typically like store the information as text. You can store the name as just text, number you have as just a number, and you can store the price as a real for decimals. But if you wanted to like advertise your fruit, how would you do that without like having pictures of them? So imagine that you had pictures of fruits, how would you actually store them into your database to serve them to your website? So this lecture is mainly about how we would go about that and a few approaches for that. So the first approach is storing them in blobs, and we will go into that right now.
Yeah, okay, so I'm gonna be talking about storing images as blobs. And yeah, so what is a blob? So a blob basically stands for a binary large object. So it's basically data stored exactly as it was inputted. So it's basically representing your image as like in binary, like in zeros and ones, and you're essentially storing that object in the database directly. So yeah, it's used for documents, images, videos, and any other multimedia files. So this is kind of like a representation of that. So this is basically displaying the binary data as an encoded string. And yeah, as you can see, like it's kind of a mess. Like there's no, like you can't read it. You can't really tell what the picture is based on this. It's kind of just a bunch of random letters that is displayed when the binary data is encoded. So this can present some problems when you're trying to store this in your database directly. And so, yeah. So the benefits of blobs basically is just that it is easy to implement because you just plop it directly in your database and there's your object, there's your image. And yeah, and that's pretty much it for that. Okay, so some drawbacks. So database storage is relatively expensive with these large objects. And if you think about it, the point of putting stuff in a database is so that you can query your data quickly, right? It's supposed to be lightweight, it's supposed to be easy. And this makes image storage not easy. Yeah, so it's expensive. And then databases are also designed for structured data. So if you saw the example that Caduce had up earlier, you had like the text and you also had the integers and you also had the real numbers, which are kind of like floats or like decimals. And all of those are like clearly defined categories, right? Everything is super structured. So with blobs, right, what you'd have a column for like a binary object, right? That doesn't really make like a ton of sense, and it's also not a structured piece of data. So that makes it challenging to store that in a database. And then backing up a database with blobs is slow. So if you want to back up your database, you want to have another database so that if one crashes, right, you still have one. You can do that, but copying over all the data is super slow because you have to copy over a bunch of these large objects. And yeah. So the second way of storing images is file path. So let's hand it over to Caduce.
All right, so let's start from the beginning. What are file paths in the first place? So a file path typically tells you where a file would be stored in your directory of a computer. And it can be represented in two ways. One way you could represent a file path is by your current location in your directory, or you could do it from the head or root of your directory. So if it was a relative file path and you were in like your amazing app and you wanted to find your Pikachu picture, you just go to the static folder that's you can see in your current location. And in the static folder, you can go to the Pikachu picture. But if you want to do an absolute file path, you have to start from the root of your directory, or in this case, users. And then from there, go to your user file folder, go to app.dev, amazing app, source, and then app.py if you want to find this file. Both ways are equally acceptable if you wish to do it that way. And in this case, servers are computers. So the thing about servers is that they also have their own directories, and they're not just like magic code running machines. So in this case, you could actually store the images on the server in its directory, like you would store it on your computer. So if you had like if you had an API endpoint that you could post images to, the server could store them in a static upload folder and then save the image in there. And if that was the case in this like image, you could store it in like images. In this case, you could actually store the path to the image in your database. So it'd just be a text field as opposed to a blob, which would be a giant binary field. So the benefits to this are faster, more scalable storage. You'd only need to store the text of the location of the image and not actually have to pre-process it, which is the second benefit, which is no pre-processing. As long as you have uploaded the image to the specified endpoint, to store it, you just need to save the path to it. Also, image backup is asynchronous. By asynchronous, I mean like once you upload the image, the server will store it like on its own, and you'll still be able to work with the API. You don't have to wait for the API to finish. And also, it's prettier. It's just a text field. You don't actually have to have a giant binary field on your database, so it'll fit more cleanly inside. However, some drawbacks are storing a large amount of images on your database, on your server directory is kind of unideal. You typically want to use a database to store a large amount of data, and storing it in its like file directory is not the best option. Also, access to the image requires the server to be up. If the server isn't up, then you can't actually find the image at all. Versus if it was in a database, and a database is hosted on like a Postgres server somewhere else, if the server was down, the database would still be up. So in that case, in the last bullet, you can see that if we use clustering, this could be kind of avoided. If you had like a server for just holding images and a server for your main app, then you could probably avoid the problem of having the server stay up in case your main app crashes. The images stay up still. Yeah, so now is our final way to store images is in a URL.
Okay, so our last way of storing images is to store an image URL in a database. So this is arguably the best way that we're going to talk about today for storing images. So yeah. Okay, so there are free and paid services that offer remote file storage. So some of these are Amazon S3, Microsoft Azure Blob Storage, Google Cloud Storage. And yeah, so basically how it works is that you actually store the image using on these remote services, and then they'll actually return you a URL, which you'll then store in your database. And then that's how you'll be able to retrieve the image. And so, yeah, so basically like there's infrastructure that's supporting strong scalability, availability, and security. So these big companies have put a lot of resources and time and have a lot of really good engineers with a lot of experience building these systems for you in order to help store images and just other media files. And so, yeah, it's a really good idea to be able to use these, or it's a very advantageous to be able to take advantage of these resources. So yeah, so you basically store the URL so instead of the local file paths, and it's going to be much more robust than anything we're making, like I said, because they have like professional engineers that have built these resources, as opposed to us who are like, we're new at this. So yeah. Okay, so here's kind of an infographic showing like how this is going to work. So you have the client and they're making a request to our app, and then our app is going to make a request to the cloud-based storage. And then cloud-based storage, in our case, AWS, because we're going to be using AWS, is going to send back an image URL to our app. And then we're going to take that image URL and we're going to store it in our database. And then, so this is what it's going to look like in our database. So we have like the same fields that we had before, the integer, the text, the real numbers, and then the text over there that is going to store this URL, right? So you can see like here we have the URLs, and there's still like, you know, some text in there for sure. But file paths can be like a little bit longer as well. And so these are all going to be like relatively the same length and like not super long. So it's an efficient way of storing the images. And yeah, okay, so the benefits. Obviously, this takes advantage of the more reliable and scalable infrastructure that was built by all of these big companies. And yeah, so our files are also secure regardless of if our app crashes, because we're not actually storing these files ourselves. We're having these outside services do it for us. And so basically, if our app goes down, right, our files, our images, they're all still there. The only way that we would lose that data is if AWS or, well, yeah, in our case, AWS, if that went down, and that would be really, really, really bad. So that's like very not likely to happen. So yeah, it's very secure. And then also we can access every file by their URL from any server. So if you have like some on different computers, you can just access them directly using the URLs, and you won't really run into any of those issues. All right. Now for the demo.
Okay, cool. Can everybody give a hand to our guest lecturers for today? Does anyone have any questions on any of the concepts that were presented as we set up demo? Okay, if not, give us a quick second to transition and we'll be back in a bit. Okay. So the first thing that we're going to start with today is this silly looking website called base64image.de. If everybody wants to like go to this website as well, I'll kind of be explaining the functionality of it and kind of like how it help us through this demo. So essentially, what we're going to be doing in this demo is that we're going to be taking an image, converting it to a base64 string, and then passing that base64 string into a function that pings Amazon servers and allows Amazon to like store that image for us in one of their things called buckets. Then Amazon will give us a link, and then that link will contain our image to it, or like, yeah, that link will contain our image such that we can do that third method that Bella talked about, and we can avoid having to store like really large things like blobs and avoid having to store like a file path. So just a quick demo as to like what this does, for example. So if I like open up my Finder, let's go to app dev, backend course, this image, not that image. This image. Okay, so this is an image of Bugcat Kapoo. So I'll just like drop it in here. Okay, so Bugcat Kapoo.jpg has been turned into like a base64 thing. So if I copy this, right, you'll see that it's like a very large for some things it'll be like, oh no, what happened? Where'd Bugcat Kapoo go? Oh no. It's like a very large string of like random letters and stuff like that. But keep in mind that this is not the same as a blob, right? This base64 string is not the same as like a binary object. You can turn those like binary objects like into base64 strings, which are like more lightweight, which is why we choose to use this option. Instead, it's not like the same as the other option. So if we click copy image, and then I'm just gonna spin up a version of the app that is like already implemented. So Okay. All right. Then if we go to Postman and then we upload this image, right? So in the version of this app that's already implemented, there's going to be an endpoint called upload where you can actually like upload this image and it will hit the AWS server such that it'll give us a link back. So it'll take in like a body with a field called image data, right? And image data is where we put in this massive string of stuff which represents bugcat kapoo in this instance. So if we hit send, we see that it gives us this link. Oh no, there's an issue here because this like first part shouldn't be none. One sec. Okay. So this is also something that we're going to talk about in this demo, but essentially this first part here that changed from none to orange bucket is the name of the bucket that you're going to create, right? And so we create this link for ourselves such that every time we hit the AWS server, it'll generate a link for us. The reason why it was none earlier was because it wasn't reading from my like environment variables that like, protected the name of my bucket. So it had like nothing there, but that wasn't going to give us anything. But if I click this link, oh no, don't go there. It's going to download an image for me, right? If you see down here, there was like an image that was downloaded. And if I open that image, it's bugcat kapoo. So this is essentially what the app that for this demo we're going to be building will essentially like do for us. Does anyone have any questions on that entire process so far? Okay. If not, let's jump into it. So I'll shut down this particular app. Okay, I'm just gonna go through some basic setup stuff. So let's create our virtual environment. And then let's pip install requirements.txt. Okay, and open it in VS Code. Okay, so in VS Code here, we see we have a couple of files. So we have your classic app.py, db.py that we're going to implement. The Docker stuff for later, we're going to like containerize and deploy our app. So just as like a basic like file overview for this, you can find the starter code in the backend textbook. Does anybody like want to follow on today and like download that code real quick? Okay, if not, that's all good as well. It'll be recorded and posted. So just a quick overview of exactly what the app kind of entails. So we have like our success response and failure response as you've seen before. We have this endpoint, just a default endpoint. And then we have this upload endpoint, which is the endpoint that you just saw me hit. So once we implement this, it'll be able to access a function in db.py, which accesses the AWS servers, which helps us store our image. So db.py is currently empty, and is as we're going to like the majority of like the implementation of images. Okay, does anyone have any questions on the file setup? Okay, if not, the next thing I'm going to demonstrate is how to set up an AWS bucket. So I've been talking a lot about like how we're like pinging our servers, we're asking Amazon to like store something for us. So now let's actually look, at how we can set up something and how we can like literally beg Amazon to be like, please set this up for us. So this like Google Amazon Web Services, cloud computing services. Okay, so first you want to sign in to your AWS account. So I've already made an account, but if you haven't made an account before you start this assignment, or before you, if you want to like try to implement images in your hack challenge app, make sure to create an account. Then what you want to do is you want to go to services, and then storage at the very bottom. Once you hit storage, they give you a whole bunch of options, and the one that you want to hit is S3. Okay, so here are the buckets essentially that I kind of like referenced a little bit earlier, in which your images are actually stored in. So note that I already have a bucket that exists called a wrench bucket, right? And if you remember, when I pinged this endpoint in Postman, it gave me something with a wrench bucket as like the leading part of the link, because this image was stored in like that particular bucket. So if we want to create our own bucket, you just hit create bucket here. You give your bucket a name. So let's just call this like voice demo 8. Note that the bucket name has to be like unique. So if you just choose like a random word, it's probably already taken. So they won't let you make it that bucket. You want to select the region that is closest to your area of development. So for us here, it's going to be US East, which is already selected for us. Then we want to hit ACL enabled. And then when we go down here that says like block public access settings for this bucket, you just want to uncheck this and then acknowledge that you've unchecked it. And that's it. So then you can just hit create bucket and your new bucket should be created if the username wasn't already taken. Okay, perfect. That's basically it for actually like setting up your bucket. So there are a couple of things on this website that you also need, in addition to actually creating the bucket itself, that's also useful for setting up being able to store images using their services. So the next thing that we need to learn about is like some credential keys that you might need to actually know that like, oh, you know, I'm the actual user who's trying to upload these images to the buckets that like I've created. So the way you can access your own security credentials with your Amazon Web Service account is if you go to your username here, and then you hit security credentials. Some random stuff. And then the important one that we want to look at is access keys here. Right. So I already have an access key that was like technically created, and it says it was last used 6 minutes ago because I used that access key to push that bugcat kapoo image into my orange juice bucket, right? They had to somehow validate that to like know it was me and let me actually push it to that bucket. But if you want to create your own access key, you just want to hit this create access key button here. It'll give you some little warning, but just hit I understand and then hit create access key. So then it'll give you 2 codes. It'll give you one code, which is the actual access key on the left, and then one code, which is the secret access key. Now, these things are probably things you want to keep private, right? Because they authenticate you and they kind of like identify you to allow you to actually like, you know, use this AWS like account and actually upload to the buckets you want. If it's something that might be wanting to keep like secret, where in our code or like which file in our code base do you might think that these variables belong in? Yeah, I kind of accidentally spoiled it there, but yeah, it belongs in the like environment variables file, right? Because we don't actually want anybody to see these. We just want to give it like almost like a surface level name that we can just access or like call them by, but not actually show what these keys are. And so this shouldn't be uploaded on like the internet anywhere. It shouldn't be pushed to your GitHub. It shouldn't be pushed to your Docker hub. So make sure that you put that environment variable file, probably called like .env, into your like Docker ignore as well as your Git ignore so that these keys don't get exposed to the public. I know I'm kind of like exposing them right now because I'll upload this video on YouTube, but I'll like delete these access keys at some point. So I don't, and I guess like the worst thing they can get is bugcat kapoo probably. I don't know. So yeah, we'll fix that at some point. But yes, so with these, let's do that right now then. So, oh yeah. Oh, okay, well.
Don't share this with anyone, and also don't make your env file public, please.
Yes. Okay, it's kind of scary, so I'll probably delete it soon. All right. But yeah, let's go into the env file and add these in. So in your Explorer, create a new .env file. So we'll need three things in this particular env file. So the three things that we want to keep secret associated with our AWS account are these access keys, and then also our like bucket name, right? There isn't really a reason why we would want anybody like else on the internet to access our bucket name. So we can also kind of like keep that private by putting it in our environment variables file. So the first thing we want in here is the S3 bucket name. The second thing we want is the AWS access key, as previously mentioned. And then the last thing that we want is the AWS secret access key. So for the access keys ones, we can just throw this in. And then for the bucket name, we just go back to the buckets. And then we're using this one for this particular demo, so we can throw this in. Okay, does anyone have any questions up to this point? Okay, if not, the last thing on this general line of keeping things secret is let's make a Docker ignore file. And as mentioned before, the things that we will want to keep secret here are the .env file, the venv file. There's no reason we want to like upload our virtual environment to Docker, the PyCache folder. And then we also want to not upload the database that we generate. So in this case, we might generate something called like images.db. So we can just put that in. Make sure to, if you ever like name your database files anything different for any of your future apps, you probably just want to Docker ignore like that particular name that you chose for your database file. So make sure just to not like confuse those because it will only recognize the file if you throw in the right name. Okay. Any questions up to this point? If not, I'll hop into the database.py file. Okay, so let's go into the db.py file. So from here, because we're actually like asking a lot of like outside services to do things for us for this particular topic, we're going to have to like import a lot of things into our database file just to be able to use like outside like libraries and outside functions and stuff like that. So we have this first one from Flask SQL Alchemy, import SQL Alchemy. Then we want to import base 64. So I'll type a few of them out and then kind of explain what some of them do. Okay, so let me run through what some of them do. So the first one is base 64, right? Remember how we went to that silly little website and like encoded our image into like a base 64 string. So we want to be able to interpret that base 64 string somehow, right? So we need a set of functions for us to be able to do that. And that's what this base 64 import is going to do for us. Then we have Boto 3. This one is to help us actually like access AWS services. Datetime is to get the current time. I believe in like the Postman response, we have like a field for when our sort of upload or like our image was like created at. So that's what the datetime library will be helpful for us for. IO is just input output, which covers this one as well. And then for here, guess extension allows us, guess extension and guess type essentially allows us to kind of predict what the file type might be from the base 64 string that we provide to it. So you know how pictures can come in formats like PNG, GIF for like an animation, JPEG, and things like that. So that's essentially will help us kind of like predict the type of the image, which will, yeah, essentially like give us more clarity in our app there. Okay, so to keep going, we have import OS. OS is the operating system again to help us access environment variables. We want to import image as a class that help us with creating our own class I'll be defining for our app. We'll import random. So the reason why we need random in this scenario, if you remember this like Bugcat Kapoo image I downloaded after like sending it to AWS and like getting it back, getting a link back. The name of this image is just like a random string of capital letters and numbers, right? It wasn't the same as the image that I originally provided, which was called bugcatkapoo.png or .jpg. I forget exactly which file extension, but essentially we don't want any like important information to be leaked in these file names. So we'll generate something random in order to kind of like also censor out the file names essentially and just get back something random when we get the new file, which is what random will help us do. Next, we need to import RE. This is for regular expressions. If you remember, Sunny, if you remember like the concept regular expressions from, if you've taken maybe like CS 2800 or something like that, at some iteration they covered like regular expressions. It's just a way for us to like identify strings into like a category. So it's a kind of like a pattern that can like identify certain patterns of strings. We'll be doing a little bit of string manipulation as we continue implementing, so it'll be helpful with that. And lastly, we would just want to import string, just like a set of string functions to help us with said string manipulation. Okay. Next, we're going to define a few constants, just like helpful like global variables for us to kind of access and use. So first is going to be extensions. Oh, does anyone have any questions with any of the imports so far? Oh, yeah. Oh, yeah. So this is just helpful for like when we turn the image into like a base64 string, these extensions will help us like identify what type that image was, whether that be like a PNG or like a JPEG that can be like identifiable or like there's some kind of like pattern formatted in the string that we generate. Okay. So with extensions, like I said, there are a couple of like image extensions, which is like what we're going to put in here. So there's like PNG, GIF, JPEG, and JPEG with an E. Next is going to be base directory. So for some like potential like file access requirements that we might use in this little app that we're going to build, we're going to need like the directory in order to like get to that file. So if you remember from the lecture, Caduce talked about like the like local file path versus like the file path that starts from like the root directory to identify a file. So this one will get us something working from the root directory. So we do os.get cwd. So this way, if we want to like access a certain file in our folder, we just give it a file path, and this will be helpful with that. Next is the S3 bucket name. So here we've already defined it in the set of environment variables, right? So we just do os.environ.get S3 underscore bucket name. And then we have the S3 base URL. So this is essentially, we're going to like construct the URL of the image that is like given back to us. So if you remember in Postman, the URL kind of like looks like this, right? And this is like sort of by our design that we made it look like this. And we can do so as follows. So first, we're going to use this like Python concept called an F string, which is a formatted string literal. Essentially, what this like allows you to do is that if you define a string and then you just put the character F in front of that string, you can access like variables to put in your string without having to use the plus operator to like concatenate things together. So what this might look like is that if we want to build a link like this, we do F and then starts with HTTPS / and then we wrap the variable that we want to put in our string in these curly brackets, right? So if you notice here, the variable name that we access is the bucket name. So we will access S3 bucket name, which we just defined in the line above. Dot S3 dot US East 1. So if you remember when we set up our bucket, we chose the region closest to us, which was US East. So that's what we defined here as well. Dot Amazon AWS dot. Yeah, so essentially this will allow us to get a URL back that looks like this one. And then notice that anything at the end of this URL is just the image name, is just the name of the file that we get back. Okay, that's basically it for defining our like constants. The next thing that we're going to do is define the class or like the entity that we'll be using with regards to this app. Does anyone have any questions on these constants that were defined? Okay, if not, we'll be moving on to defining the class. So the class that we're going to use in this app is called asset. So we give it the input db.model like we did back in PA4. Give it a set of doc strings, so asset model. The table name, we're gonna call it assets. So yeah, there's gonna be a couple of like fields here, like we did when we defined like for example, like classes and courses in your 4th programming assignment. So we'll have an ID, db.column, db.integer, primary, key equals true, auto increment equals true. We'll have the base URL, db.column, db.string, nullable equals true. And then we'll have a field called salt. So essentially what salt is sort of like the tool that we'll use to actually like make those randomized image names. If you remember from last week's authentication lecture, we also used like the salt concept to like hash some like credentials that that you might want to store in the database such that it's not just stored as like plain text. This is going to be db.column, same as above, so I'll just copy and paste. And then we have the extension, which is just the type of the image, like PNG, GIF, JPEG, JPEG with an E. Also the same, so I'll copy and paste. Next, we just have the width and like the height of the image, right? So this might be helpful for you in an app. For example, if you want to like upload an image that's like too big, maybe you want to like in terms of like dimensions, maybe you want to like process it a little bit differently. So that's what things like width and height might be helpful for. And then lastly, we have a field called created at, which is just like the time that we chose to like upload this or like create this particular asset. So this is going to be db.datetime, which conveniently for us is like a recognized type in SQL Alchemy. And then nullable is false. Okay, and then the last thing that we're going to do for today's lecture is just like do the initialize function. So init self quargs. If you remember, the quargs is like the keywords argument where you can kind of like extract any key from it if it exists. And this initializes an asset object. And then this will just be self.create quargs.get image data. So this create function doesn't exist yet. We'll be implementing that in the next lecture. And if you remember, the body that we pass in is just a JSON with like a field called image data, right? So we're just going to be extracting that image data from the request. Oh, sorry, yes. Up here, these should be nullable equals false. I forgot to change them. Oh, okay. Yeah, that's it. Anyone have any questions? Okay, if not, let's go to the Kahoot for today.